Okay, so what would that be? Well, the even numbers would be 2, 4, and 6. Okay. So A here would be an event. It would be the two-sided face, the four-sided face, and the six-sided face. That's my event. Okay. Let's let B. We're going to let B be the event that let's let B be the event that we get a high roll. Okay, and then that means that I'm getting 4, 5, or 6 as my total. Remember, x was the value of the roll. Okay, well then B is what? B is the four-sided face, the five-sided face, and the six-sided space. Six-sided face, sorry. Okay, and we can see that these are not equal events. Okay. These are not equal events. Why? Because, for example, okay, 5 is in B, it's one of the high rolls, but it's not an even roll, okay? So different events can contradict each other, they can occur at the same time. For example, if I choose, if I say that I want the event where my roll is a multiple of 4, the value of my roll is a multiple of 4, well, there's only one face that has a value which is a multiple of 4, which is this one here, with a 4-spotted face. And you know, if something is a multiple of 4, then it has to be even. So, for example, all of the multiples of 4 are going to exist in the even rolls. Okay, or for example, I could say that I want a multiple of 4, but all of the multiples of 4 are inside the high rolls. Okay, so if I get a 4, I'd be guaranteed to have an even roll. If I got a 4, I would be guaranteed to have a high roll. Okay. 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 So these are not equal events. Okay. So let's do a slightly different example. Let's say I toss a coin. Okay, well then my outcomes, that's my sample space. My sample space is equal to, I'll call it S. And I only have two possible outcomes. Either I get a head or I get a tail. Okay, I only have two possible outcomes. Okay, but you know, this could be an event. Let C be the event that we achieve any result. Okay, well then C would be H and T, which would be the same thing as S. Okay, so that's totally acceptable as well. Okay, and that would be an example of another sample space and another event. Okay. Let's talk a little bit more about, say, sample spaces and some events. So, for example, say I'm choosing people from a population. Okay. Say I have, say I have everybody on a register and they have some unique identifying number. Okay. And I have a machine which selects people at random. Maybe everybody is equally likely, maybe they're not all equally likely. Doesn't really matter. The sample space then is all of the possible people that I could select. Okay? I could say that I want the event that that person is male. I want the event that that person is over the age of 75. I could say I want the event that that person is less than 6 months old. I could say that I want the event that that person has completed their leaving cert. Anything. Those are all events, okay? And in any case, there will always be some subset of the population for which that statement, which defines the event, is a true statement. And that would be the subset that I am interested in, okay? So say, for example, I have my deck of cards here, okay? This is, I believe, a full deck. I haven't actually checked it. But we know that in a deck of cards we have different suits. So, for example, the King of Clubs is a club, the King of Hearts is a heart, the Six of Diamonds is a diamond, and the Four of Spades is a spade. Okay, 4 different suits. So, okay. Okay, and I'm just going to select one at random here. Okay, so let's say I pick a card, okay, and now I'm interested in the event that I get a spade. Okay, the event that I get a spade. Well, the sample space, okay, is all of the 52 cards. Okay, all of the 52 cards. And the event that I get a spade is the collection of all of the spades, Ace of Spade, 2 of Spade, all the way up to King of Spades. So say, for example, I draw a card at random here, and okay, I missed, I got the 9 of Hearts, okay? That would mean that I picked somebody who was in a different set from the set, a different subset from the set of spades, okay? So, that's another example using a slightly different context, okay? Another thing I could say is, okay, let's take the population, or my set of things that I can select from. My experiment will be that I take a student at random from IT Tala over TU Dublin Tala, and let's say that the event is that I'm interested. That the event is that the student had a GPA of over 3, okay, or over 3.5 maybe, whatever it is, okay? There would be some collection of students that would satisfy that definition, and then that subset of students would be the event. Okay, now here is something which is not always true. Equally likely outcomes. Okay. So, in some cases, in many cases, in fact, okay, each outcome in a sample space is considered equally likely. Okay? Equally likely. What does that mean? Okay, that would mean that there'd be no particular favoring or bias towards achieving one particular outcome. Okay, so remember, let's go back here to my dice roll set. Okay, these are my set of outcomes, the faces one, the 6 different faces of the die. Okay, and if the die is fair, that is, if it doesn't favor any particular face, then I would believe that these are all equally likely. Okay, but that's not guaranteed when I have a die. Okay, this die could have a, well, this one's, you know, translucent so you can see through it, but if the die were opaque, it might be hiding a small lead weight or something like that, which would always cause it to fall on a particular side, in which case, even though I could potentially have 6 different outcomes, the probabilities of them would not be the same. They would not all be equally likely. In the same way, if I had my sample space for a coin, okay, we see that I have the 2 outcomes were heads and tails, okay, and heads and tails, if I have a fair coin, I would assume those to be equally likely, but maybe I don't have a fair coin. Maybe I have like a trick coin or a bent coin or something like that that will tend to fall on one particular side, okay? In that case, those outcomes would not be equally likely, okay? So equally likely outcomes, sometimes the case, and we'll look at examples where they are the case, but it's not always guaranteed. I'd also like to mention here that there is a kind of a bias you can have in your thinking where you automatically assume that outcomes are equally likely, okay? I think a really good example of this is, when babies are born, and the doctor cuts the umbilical cord, that heals in a particular way, so their navel will either end up as like an innie or an outie, okay? And if you ask people what the probability of an innie versus an outie is, most people assume it's 50-50, that there's 2 possible scenarios, so that they should be equally likely, but it's not. A navel which is an innie is far more likely than a navel which is an outie. That's something to be aware of, okay? Another thing, for example, you could say is like, I could say, okay, well, I could have a yes or no question, and you could assume that, you're 50% likely to get a yes and 50% likely to get a no. But of course, that depends on, the preferences of the person that you're asking, okay? If I was asked, would I rather Thai food or Indian food, it might depend on the night. But if I were asked, would you rather win €1 million or get executed, I know which one I'm going to pick. So there's a very drastic difference sometimes between A or B or yes or no type questions. It's not always a 50-50 breakdown. And what I'm just trying to stress by that is, don't assume that outcomes are necessarily equally likely unless you have some kind of reasonable belief or some kind of logic to assume that they should be. Okay? So for example, when I was discussing the idea that my belief regarding this die is that it is a fair die, what is that based on? Well, that's based on the fact that I can see that it's an almost perfect cube, that it doesn't feel in my hand to be weighted in any way. If I kind of spin it, it seems to move naturally. It doesn't seem to wobble or have anything like that. I can see through it in the light. I can see that there's nothing inside of it that might influence the roll. So I would assume now that this is a fair die, but I have a justification for that belief. Okay, in the same way, if I were to say, okay, I have my deck of cards here, and I have 52 cards in the deck, and say I shuffle them and I draw at random, well, I would assume then that if I draw at random that every card is equally likely. But it might be the case, for example, that one card had, say, something sticky on it, so that it was sticking to the card above it like that, in which case I would never get the card above it, okay? That would be kind of blocked. So there could be more going on which would cause me to change my belief, like I said, okay? So equally likely outcomes is really only something that I should believe if I have some kind of justification for that belief, okay? So I think what we've talked about here is a pretty good cover of the idea of the experiment, the outcomes, the sample space, and what I would mean by an event, okay? In the next video, I'll get on to talking about what I mean by the probability of an event, specifically in numerical terms, how I would go about calculating them, and so on, okay? So hopefully that's informative. I realize this is a longer video. I just decided not to cut it halfway through. So I hope that that's been something you have, engaged with, and that you learned something from. Okay, so in the next video, I'll talk about calculating these things, and from there we'll do some more involved examples and so on. But this is just to explain my terms and get all the ideas out. Okay, take care, everyone.